Thank you for that thunderous applause. Well, okay. Good evening, South Cheshire Astro. Pleasure to be back once again to talk to you. This evening, 2 short talks. The first one being robots on Mars. So I'll be saying a brief little introduction about Mars and Martians, and then looking at a few landers and rovers that are on Mars, asking the question, essentially, why are they there and what have they found? And then finishing with where do things go next. So we Earthlings have had a fascination with Mars for a long, long time. For some of us, it dates back to War of the Worlds, whether that be the radio or the book or the film or the musical. But if you say The Martian to a youngster, they won't necessarily think of War of the Worlds. They'll probably think of Matt Damon in the more recent film. But if we just take a second to remind ourselves how amazing it is that there are robots on Mars. 1 million years ago, we were swinging around in the trees. 100,000 years ago, we were living in caves. And now, we can build machines, put them on top of a rocket, send them to another planet, and get images like this. High-resolution images taken from a rover doing a sweep of the landscape, as well as digging in the soil, telling us or trying to answer the question, is there water there? Is there life there? Was there water there? Was there life there? There are definite signs of water. There are dried up river channels. We think the water is perhaps subsurface. The surface looks dry. Perhaps we go below the surface in order to find water. And if we do, where there's water, there's often life. If you have the energy from the sun, if you have water, if you have the right minerals and elements, then some people say life is inevitable. So we're exploring Mars to try and answer those sorts of questions. I'm not going to attempt to cover all of the landers and rovers that have been to Mars. There's been 1 Chinese and a number of American rovers. I'm just going to go through a few of the NASA rovers. From the 1970s, Viking, through to Pathfinder, and then Spirit and Opportunity. In the noughties, there was another lander, and then in the teenies, in 2012, a fairly big rover called Curiosity, and then more recently, the 2020 exploration of Perseverance, otherwise known as Percy to his friends. I'm not going to go in detail through all of them. I'm just going to say a few words about the ones that I've highlighted there in red. So it starts, well, for me it starts in the 1970s, because I remember Viking landing on Mars. There's Carl Sagan providing a bit of scale to a model of Viking out in the desert somewhere. And I remember in the 1970s seeing the first color pictures come back from Mars. And although I was inspired by the moon landings, I was also inspired by the fact that in the 1970s it was possible to get color images from another planet. I thought that was absolutely amazing. That Viking lander was just a lander. It stayed put, couldn't go anywhere. There were actually 2 landers, but neither of them were rovers. Actually getting to Mars is not quite as difficult as you might assume. You don't need a particularly large rocket, nowhere near the size, for instance, as the rocket that actually took us to the moon. The Saturn V in the bottom right took astronauts to the moon, but the rocket taking rovers or landers to Mars is much smaller. Not because Mars is easier to get to in terms of closer, but simply because landers and rovers might only weigh a fraction of a ton, or maybe a ton or 2. But the Saturn V had to lift more than 100 tons into orbit in order to get 3 astronauts to the moon. So yes, the moon is a lot closer, but the spacecraft was a lot heavier. So getting to Mars in that sense is easier, simply because we're sending less mass, less kilograms there. Let's have a look at how Spirit and Opportunity did it quite a few years ago. Once you've put them on top of a rocket and sent them to Mars, the spacecraft itself comes into the Martian atmosphere and slows down by aerobraking. In other words, air resistance slows it down. Eventually, it's slowed down enough to deploy a parachute. It's still supersonic at this point, so the parachute has to withstand supersonic speeds as it hurls through the atmosphere. And then you have the problem of, well, you've slowed down a bit, but how do you actually get the lander, the rover, on the surface? The rover is in the middle of this pyramid structure. And the question is, how low do you go before you decide to land it? And how do you land it? In this particular case, because it's not too heavy, they decided airbags was the way to go. You explode some airbags, and then you slow down as much as you can, and then you cut it loose. And literally, it just bounces its way to its final resting place. So you don't have to be too precise with how high you are. You don't have to worry about Martian winds taking you left or right and a bit off target. You just drop it and let it bounce until it stops. The accelerators on board, they were watching what was going on. It took 28 bounces before it finally came to rest. So yes, the rover inside has to be packaged up very carefully to make sure it can withstand that amount of bouncing around. Once it finally comes to rest, they deflate the airbags, and then it unfolds itself. It's designed as a little pyramid such that when it unfolds, it automatically rights itself. Very clever. Once it's unfolded and the little rover inside, Spirit and Opportunity were relatively small, only about the size of a coffee table or so. The first thing that happens is the little rover, let's assume this is Opportunity. Spirit and Opportunity are effectively duplicates, just sent to different places. As soon as it's on the surface, it unfolds its solar panels. Spirit and Opportunity were solar powered. It was absolutely critical they had solar panels that could pick up energy from the sun to charge the battery to power the instruments and indeed to keep it warm because it gets very cold on Mars. So the solar panels have unfurled, and now a mast comes up with a stereo camera on the top, and the first thing it does is take a look around, make sure it is the right way up, just in case, and get an idea of where it is and perhaps decide where it's going to go. After a little bit of checking and a little bit of diagnostics back in mission control, they give the order for it to start roving. So then it starts to unpack itself. Its wheels deploy. It comes up on its wheels. The front wheels then unpack. It does another check of where it intends to go to check there are no rocks in its immediate path. So it has a quick look. Yep, down in front of it, the stereo camera tells it if there's any rocks in the way, and then it starts its journey. Spirit and Opportunity were designed to last at least 3 months. When people design spacecraft, they are always conservative. So when they say 3 months, they hope it's going to be a lot more than 3 months. Spirit and Opportunity. Spirit lasted for quite a while. Opportunity lasted for 14 years, despite the fact that its design lifetime was 3 months. Very conservative. What ultimately determined the lifetime was either do you break a wheel to the point where you can no longer trundle along the surface, or do you get to the point where you can no longer charge your batteries. In the case of Opportunity, the 3-month lifetime turned out to be 14 years, and the reason it actually died in the end was because it was entering a Martian winter and it was unable to recharge its batteries. This is what it normally looks like. As seen from above, the camera can effectively look down and take a selfie, and this is a selfie of what the solar panels looked like shortly after landing. Relatively clean, relatively reflective, but unfortunately Martian dust gets everywhere, and after a few months you can end up the same selfie looking like that. You can hardly see the spacecraft anymore because the Martian dust on the solar panels is the same color as the Martian dust in the background. So you can appreciate that it's almost invisible. Great camouflage, but who wants camouflage when you're on Mars? It means that the solar panels are becoming ineffective. So they could see the power levels dropping. Occasionally, a little dust devil came along and blew the dust off the solar panels. You might ask, why didn't they simply have a brush to brush it off? But unfortunately, Martian dust is a bit like volcanic dust on Earth, volcanic ash. If you try and brush it off, all you do is scratch the solar panels and reduce their efficiency. So they waited for dust devils to blow them clean, and occasionally they did, and that extended their lifetime. But you do have to survive the Martian winter. The tilt of Mars is very similar to the tilt of the Earth. You can see there about 23, 24, 25 degrees relative to the orbit around the sun. And a Martian day is very similar to an Earth day. Earth day is 24 hours, a Martian day is a little more, 24 and a half days. So in that sense, the seasons are very similar. The day and night cycle and the seasonal cycles are similar. But the rovers have to keep warm. If they freeze, they die. The electronics can't go below a certain temperature. And the day temperature on Mars might be 20 Celsius or so, if you're lucky, but the night temperatures can fall to minus 100 or colder. So it's absolutely imperative that the solar panels charge the batteries, that keep the heaters on, that keep it going overnight, especially over the winter nights. But what eventually got Opportunity after 14 years of sterling service is that it was approaching the night of a Martian winter. It needed to recharge its battery, and there was a dust storm, a huge dust storm that covered a huge fraction of Mars, and it effectively blocked out the sun. And if it blocks out the sun, you can't recharge your battery, which means it gets cold, and ultimately it fails. So the last transmission from Opportunity in 2018 was the following: battery low, getting dark. And that's the last we heard of Opportunity. Yes, sir?
I just wonder why I know there's an international ban on nuclear power. I'm not a big fan on this. The nuclear power reactor kicking when the solar power didn't work. They'd have been okay.
Okay, the question was, why didn't they use a nuclear reactor? Nuclear reactors are generally too big and too heavy. They are fine for running nuclear submarines, but nuclear reactors don't work so well for small objects that are the size of a coffee table. Sorry?
Why were they internationally banned?
Because why were they banned? Because nobody wants a nuclear reactor going up on a rocket. What happened the last time a rocket was launched? It came down again. If you remember that a few weeks back, nobody wants a nuclear reactor landing in their back garden. So the idea of launching nuclear reactors in space has been effectively banned. So I'll be getting to that in just a second. So Opportunity and Spirit had solar panels, and they had problems charging them, and that is going to be always a problem with solar-powered spacecraft. NASA decided that in future they wanted larger rovers, so not just the size of a coffee table, but the size of a car, much larger rovers that are capable of going further and having more instrumentation on board, but that means a greater power, and they didn't want to be subject to the vagaries of solar power and dust storms on Mars. So when it came to Curiosity, and I'm going to talk about Perseverance, which effectively is the same sort of rover as Curiosity, it came into the planet in much the same way. Perseverance was launched in 2020 and landed in 2021. It still has to break through the atmosphere. It still has a parachute, but it has a different way of landing because it's a much heavier rover. So let's see how they did it with Perseverance. Getting there, pretty much the same for any mission to Mars. Again, when you hit the atmosphere, you slow down as much as possible. That's Perseverance inside its shell, being shaken to bits. As it's coming in, there's a small amount of control as to where you're going to go. There are little jets that can steer it. Again, a supersonic parachute slows it down. But this now weighs more than a ton, and therefore you can't just put airbags around it and drop it. So the shield is jettisoned, and then Perseverance is dropped. But it has a framework with jets to slow it down. Those jets would kick up far too much dust if they actually tried to land with those jets. So what they do is steer to where they want to go. Downward-looking cameras are trying to work out where they should be landing, And autonomously, this system, not under control from Earth, autonomously, this system picks out its landing site. When it gets close, we keep the jets away from the ground, and Perseverance is lowered to the surface on a crane. As soon as it touches down, the cables are guillotined, and the sky crane flies off and crashes somewhere else, leaving Perseverance on the ground. Because they didn't want to be subject to solar power, there's a radioisotope thermoelectric generator, an RTG, on the back end. Not a nuclear reactor, but something that is not subject to solar power. It'll provide power to the systems for years, regardless of what the sun is doing. And this long, slow pullback reminds you that regardless of how many rovers you've got on the planet, it's still a pretty big planet to explore. Even if you had 1,000 rovers, you couldn't possibly explore the whole planet. So there's Perseverance, otherwise known as Percy, and sitting beside it there is Ingenuity, or Ginny, a little helicopter that it took with it. So Percy here, like a nervous father, is continually keeping an eye on the daughter Ginny, trying to make sure it hasn't run off and gone anywhere. So it's a nice little set of selfies here of Perseverance looking at the camera and looking at Ginny. But how do you take a selfie like that? We're used to the idea that if you've got a phone, all you do is pick up the phone, click, and you've got a selfie. How do you take a selfie like that? There are cameras on the top of the mast that we can see there, but there's also cameras on the end of the robot arm that it uses to drill rocks and do tests and do scientific experiments. And so a selfie is not just a snapshot, it's actually a whole load of images which is built up by taking images from the robot arm. There's the robot arm moving, and circled is the lens of the robot arm camera. You can see that as the camera moves, the lens stays in the same place, but it ends up pointing in different directions to make a montage, and all of those images are then stitched together to make the final selfie. So in other words, you don't actually see the robot arm itself because they have enough images that they can effectively take that out. And it looks as if you just have a camera floating in front of Percy taking the image. So there's Percy, but how did the helicopter Ingenuity get there? Well, it basically stowed away underneath Percy. As it was coming in, there was a plate protecting the helicopter. It's there underneath Percy, and once it had decided that everything was safe, it dropped Ingenuity and then trundled away to leave Ingenuity exposed for its first flight. Why do you want a helicopter on Mars? Well, the idea is, there's Ingenuity down in the bottom left-hand corner. The idea is if you take a helicopter, something you can't do on the moon because there's no atmosphere, but on Mars you have an atmosphere, it's thin, but there is an atmosphere. You can fly a helicopter, which means for future rovers, if you wanted to, you could fly the helicopter over the horizon and scout a much larger area and basically tell the rover where to go. Watch out for this, go left, not go right, and if you go over the next hill, you'll find this, that, or the other. So the idea of having a helicopter for scouting was thought to be a useful thing to do. So this is one of the flights of Ingenuity. I'm not sure if the sound comes across very loud. There's a little bit of wind noise, and then the helicopter lifts. I think the sound isn't coming across loud enough for you to hear, but there's actually a hum. You can actually hear on the soundtrack the hum of the helicopter as the blades are spinning. So you're actually listening to a spacecraft on another planet. The idea was not only to prove the fact that in principle helicopters could be useful for surveying the ground and flying ahead of the rover to see what's out there, to scout out the next system to look at, the next set of rocks, the next geological structure to look at. It's also thought that this could be a way of exploring other worlds. Some worlds do have atmospheres. For instance, there are plans to send a helicopter to Titan, one of the moons of Saturn. That atmosphere is thick enough that in principle you could have a much bigger helicopter and a lot of instruments rather than just a camera. You could have a whole load of scientific instruments and actually explore other worlds, not with rovers, but with helicopters. When it comes to NASA sending out missions throughout the solar system, they're always aware of public relations, which is why when it came to the 2020 mission, Perseverance going to Mars, they basically said to the general public, if you want to come along for the ride, let us know and we'll give you a boarding pass. So I took advantage of that. A few years before it left Earth, I got myself a boarding pass for Perseverance. Those boarding passes are stored on a little piece of silicon underneath a plate on a bracket there, and that bracket is sitting at the back of Perseverance there. So in other words, at the moment, Perseverance is roaming across the surface of Mars, and I've gone with it. My name is sitting there across the surface of Mars. Not only me, let's be clear about this, not thousands of others, probably millions of other people have got their name. It's just a free service that NASA offer. If you want your name to go to Mars, if you want your name to go to Jupiter, it's an option. Basically, all you do is sign up for free, they give you a boarding pass, and then they put your name onto the system. For them, it adds an extra milligram to the weight of the craft. It costs them almost nothing to send your names, but it's good for public relations because then people feel invested in the whole enterprise. I'm there with it. I'm exploring Mars with it. So why explore Mars in the first place? Well, we want to understand it as a planet. We have some understanding of how the Earth is put together in terms of geology. We're still trying to understand climate and climate change, but exploring other worlds will tell us a little bit more about our own planet. And really, we want to answer the question, does life exist elsewhere? We know life exists here on planet Earth. Does it exist anywhere else? Did it ever exist? We think water is under the surface. We think water has flowed. We see gullies. We see dried up riverbeds. So it looks like water, liquid water, has flowed on Mars. And it also looks like the ice caps have water underneath them as well. So if water did exist on Mars some time ago, is it possible that life did evolve on Mars? Maybe it's still hiding under the surface. So just scratching the surface of Mars doesn't tell us that. But the other reason for exploring Mars, for some people, is, well, ultimately, one day we'd like to go there to prepare for human exploration. That, of course, will be a much bigger mission. We don't just send a one-ton rover. If we want to send astronauts, just like going to the moon was a lot more difficult than just sending a small robot to the moon, so sending astronauts to Mars will be much more difficult than just sending a small rover. But maybe it will happen one day. In preparation for that, Perseverance is not only scratching the surface, drilling into rocks, trying to understand what the rocks are made of, what the atmosphere is made of. It's also collecting samples, one of which you can see there sitting underneath Perseverance. The idea is to collect rock samples and samples of the atmosphere and one day bring them back to Earth. Perseverance is a very complex scientific laboratory, but there's a limit to what it can do. We could do far more if we took those samples, brought them back to Earth, and then analyzed them with the various sophisticated equipment we have back on Earth. But how do you get a sample that's been taken on Mars back to Earth for detailed study? Well, the plan was figure out how to take the samples, and then later we'll figure out how to get them back to Earth. That was NASA's approach. They thought with NASA and ESA, the European Space Agency, they could probably get a return mission sorted out. And what they originally had planned was this as a return mission. Perseverance eventually would be joined by another craft, which would then touch down, not a rover, just a lander. Perseverance would then go up to meet it, and it would take all of the samples that it had been collecting for the last 1, 2, 3, 4 years, whatever it happens to be. It would take all of the samples, the rock samples, the atmosphere samples, and it would transfer them into this lander. It would then seal it up. And then how do we get that back to Earth again? Well, it's actually put into a small rocket. And that rocket is then launched from the lander, and off it goes back to Mars orbit. And there's Perseverance watching it go home, back to Mars orbit, and then ultimately back to Earth. Quite a few dozen samples, in principle, could be returned that way. That was the original idea of Mars sample return, the original idea as put together by NASA and ESA. They haven't actually implemented that yet because they've now figured out that Perseverance cost a certain amount of money, and it looks like a Mars return will be more expensive than they had first thought. So they are trying to figure out it's great that Perseverance is taking these samples. Can we figure out a cheaper way of getting those samples back to Earth? So that's what they're working on now. But what's next? Well, in something like 2028, only 2 or 3 years' time, ESA are already working on the next Mars rover, a little bit smaller than Perseverance, but because it's European, there is a significant UK involvement here. So yes, the UK are going to put a rover on Mars. This particular rover, called Rosalind Franklin, differs from many others. Yes, we're back to solar power again. Not everybody can afford radioisotope generators for the power. So we're back to solar panels, but the difference with this rover is that black box on the front, because that is a drill system. And it will be possible to drill down not just a few centimeters below the surface. The intention is to drill at least 2 meters below the surface. If there is subsurface water, it is hoped that this rover, called Rosalind Franklin, will be able to find it. So this is one step more towards trying to establish whether life does exist or whether life did exist on Mars. So it's being built by Airbus UK. So here's the technicians putting it together. It looks like it's a 6-wheeled rover, but there's only 5 wheels on there. I'm not sure if anybody noticed that 1 wheel is missing and it's being replaced with a shopping bag. I hope that they realize that. So yes, it's being put together. It's obviously still a rather complex beastie. And that is still being built, as best I know. The intention is hopefully launch in 2028. So a lot has happened in the last few decades. A lot will be happening in years to come. And if you want to know more about landers and rovers on Mars, then if you look at the relevant web pages from the national sites, either NASA or the European Space Agency or the Chinese Space Agency, they all have information about what their rovers have been doing and what their rovers will be doing. Thank you all very much.